The purpose of this tutorial is to provide some introduction into using Engineering Equation Solver, or EES, EES. And when you first start the software, this is what the window looks like. You see there's an equations window, and this is where you're going to type all your equations. And once you do, then you hit this calculator button. You could also just hit F2. You could also come here to the calculate menu and come down to solve. And that's what it's doing, is solving all the equations that you put in there, and it's gonna open up a new window. So for instance, if I have one equation, d equals 5, and I hit the calculate button, then I come up with it generates this new window, then my solutions window, and again that's where it's going to display all your results. So I can now type in some other equations. Maybe I have a variable called p, and I know that it's related to my variable d with the following expression. I hit the calculator button, it solves for p as well. But one benefit in EES is the fact that you don't have to, if you have many equations, you don't have to solve for them explicitly in terms of a single variable. So for example, consider the scenario where we have another variable q, and the equation that we're given maybe looks something like this: minus 4 times p squared equals 5 times q. And so at this point I already know the value for d, and I already know the value for p, and so I can easily just solve this algebraically by dividing the 5 over, and now I've got an expression for q. But in many cases we have equations that are much more difficult to solve explicitly in terms of this new variable, whatever it happens to be. And EES can handle that in the background. There's a few caveats to that, but it's basically just solving your system of equations as you have them written down. So I can hit the calculate button and I get a value for q, and that's what I would get if I solved this by hand and manipulated it algebraically to get in terms of q and substitute values for d and p. And so that's one benefit that you have with this software is, again, you can just write down a system of equations. So even if I have, let's say I have a linear set of equations. There's my first equation, x plus y minus z equals 3, and then maybe it's 4x plus 5 times y minus z, and that equals 4. If I hit calculate at this point, it's going to tell me that I don't have enough equations. I've got 2 equations, but I have 3 variables. So obviously mathematically it's not going to work for me, so I need a third equation, and let's assume that that was minus 3 times x minus 4 times y plus 7z equals negative 4. And I'm just literally making up equations, but the thing I want to illustrate here is that I have 3 equations, and I can just type them in as they're written down, and now it solves that block of equations, and this is what I get for x, y, and z. And so as long as you don't have errors in your equation such that it causes instabilities with the numerical solution schemes in the background, then you'll be able to solve your system of equations, how many ever you have. So that's one advantage to using this software. Again, you can just type your equations in. The other advantage is that it has units built into it. And I'll draw your attention down here to the ribbon at the bottom of the equations window. Right here you see that it's in SI units. There's a C for Celsius, kPa for my pressure, kilojoules for my energy, and then mass and degree. If I just click on that, then it comes up with these preferences. So I can change them if I want to. I'm going to keep them as is, but I need to be careful to use the units when I calculate my numbers that are in this system, my preferences that's listed here. And so if I have now d equals 5 meters, let's give it a unit, and the way you give it a unit is you just put a square bracket and place the units inside of that. And so now you see that I've got the same type of thing in the solutions window, d equals 5, but it's listing a unit on there. And if I would have said, well, let me just come to the solutions window, and I can take this, and if I right click on that, then I can display a secondary unit. So maybe I want to know what this is in inches. So I'm not going to, EES is not going to use that number for any of its calculations, but it's nice to be able to display once in a while if you're interested in seeing units other than those with whatever the fundamental preference is. And so maybe I have F equals 4 feet. And so the foot is the unit that's represented here because that's how I defined it. But now if I take this and I say that H equals D plus F, so I'd get 4 meters plus, or 4 feet plus 5 meters. The result should not be 9 because I need to convert one to the other before I add them. But EES is going to take the numbers that you put in there and do just that. And so you see that H is 9. But you also see that I have this potential unit problem detected. And it's very obvious what that is. The first is that I haven't given H any units, and that's not quite as obvious. But it just displays this. So I formally gave units to both D and F, but I did not give anything to H. And so the way that I do that here is I right click, and let's pretend that well, let's not pretend, I made a mistake along the way, and I think I had everything in meters, but apparently it wasn't, so I hit OK. And now this has a unit next to it like it should, but I still have this problem. And so when you're doing calculations, you want to make sure that these potential unit problems go away, because it's not just a matter of did I get something slightly wrong along the way. In this case, it's a very wrong number. 5 meters plus 4 feet is not 9 meters. And so I could come in here and I could change this to feet. And it's still 9. It's using those numbers 5 and 4. But that also gives me this error. So the way that you have to account for this is either outside of the software, just change this value to the fundamental preference unit, which would be meters in this case. But what I'm going to do in this example is I'm going to use the convert function. And I'm going to convert from feet to meters. And so it's 4 feet, but I want to convert that to meters, and then I want to add those together. So now when I hit calculate, you notice that my unit problems go away. And this is now expressed in meters. And maybe I just want to double check that to make sure that it is what I thought it was. And indeed it is 4 feet. And now I can add these together. I can take 5 meters plus 1.219 meters, and I get 6.219 meters. And my unit problem went away. So that's kind of a brief overview to EES. We'll talk about additional functionality that you'll want to take advantage of, plotting, making use of the thermophysical properties that are built into EES. There's tables of data for water, especially. We're using a lot of those. But all the gases that you'd want to use, whether it's ideal gas properties or real gas properties, we can specify in EES, and we can look up all the thermodynamic variables that you would want to have in order to do some analysis of either a component or a loop. And so as the course progresses, you will get more and more familiarity with using this, and hopefully gain an appreciation for what it does for us and why we were using it in the first place. All right, well, that concludes this tutorial. Thank you.